Welcome to 100th edition and celebration of NAB show. What we're going to talk today is we have very accomplished set of panel here. We have Thomas Bonchon from ATEM. We have Mauricio Mesa from Spin Digital, Thomas Kramer from Men Concept, and Ali Debi from Simwave, who came all the way from Vancouver. So very accomplished set of people. My name is Ravi Vella. I'm from Intel Corporation, and I'm going to get started into really entertaining stuff. So just a little bit preamble. 100 years back when NAB started in Chicago, Drexel, it was not even about the TV. It was about the radio. So it was called like National Association of Radio Broadcasters. And look at after 100 years, here we are. More than 30 broadcasters showed up, and 3 points were very keen to them. Number one was copyright issues back then. Then the second one was related to artist royalties, and the third one was a spectrum. So after like in a fast for 100 years, even the transition of broadcast took place, TV, then digitization happened. Here we are again, like some of these are still very prominent. But in this particular presentation, we're going to talk about like a next generation 8K codec. So we have been celebrating 100 years now. So what's the next decade or like 2-3 decades going to look like? So this panelist with their highly decorated accomplishment in the industry and in the ecosystem in the creation, they're going to give a very unique perspective. So this is thank you 8K Associate for putting this and sponsoring this panel. And I just want to give you like a level set little bit. In 2020, Tokyo 2020 Olympics happened in 2021. We had a special permission to broadcast this entire Olympic, 8K, 60 frames per second, high dynamic range. We use a protocol HEVC to distribute at selected locations around the world. So class-to-class latency from Tokyo to your TV set was less than 2 seconds if you use the protocol RTP, and 14 second if you use HLS, but it can give you like as much a scale that you want. So in a nutshell, the whole media workflow is divided into 4 parts. And here we are only going to focus on one compression part, but I just want to give a level set here. So capture where the content come from in case of like a 4K, what we use in the Tokyo Olympics is 40 gigabits per second. That's how the content is to come from. From there, it gets to your encoder. And that's where like several standard and this companies here will discuss about like how the progression happened. HEVC here was used, taking the signal of 48 gigabits per second into like an 80 to 100 Mbps, which is we call a distribution, or 250 Mbps, which is called a contribution signal. That signal was compressed, encoded within like less than 200 milliseconds. So here, panel previously I talked about like a latency. Here in end-to-end 8K, you can deliver in 2 seconds. So that's what like how powerful and the technology is there. But the democratization happens when the scale and everybody starts picking up. And this is just how common, how media ecosystem works. Then you take that content, distribute over the open internet, and then display on the decoder. So this is how like an average like a media workflow looks like. Same thing with the 8K. And with that, actually, we're going to go to the next slide. And this is how like this thing looks like. So it shouldn't be like see as oh, this is just a technical presentation. Just take a look at it like how 8K was streamed. So as a human side, before I get into the technology, there was a match we were watching. First, actually, my experience watching 8K was in Rio Olympic in 2016. Here, there was a judo match was happening, and one of the Colombian judoka, her contact lens dropped on the floor. So not only camera captured from the tatami match, you can literally see the marking on the contact lens. And it is so surreal, like even if you're in a stadium, which we watched few matches, we could not able to get that detail. So that's where like it's a very beautiful moment in terms of like how you basically get to feel that real life immersion. So here in a theme wise, we're going to talk about more pixel, better pixel, faster pixel, but also let's not forget audio. Audio was delivered in 22.2 channel, 5.1 and stereo. So putting all this together will give you like a stadium like immersion at your home. And that is the value of 8K. With this right now, I want to get to the first two attempt. And Thomas, just give us basically, you've been working for a very, very long time.
Yeah. So at that time, we've been active on 8K for some time. For those who don't know us, ATEM is doing video compression and delivery software. And I'm working in the office of the CTO and the opportunity to work on new technology like 8K. And in fact, our first foray in 8K was quite a while back in 2007 when we did super high vision prototype for NHK. I actually daisy chaining 16, if you can imagine, AVC encoder. And the results were really good. We also worked on 22.2 audio. But back then, back to your point, Ravi, that was not at scale. You can't scale a setup with 16 encoder like that. So we realized that back in 2012, we started a full redesign of our compression stack. So at that time, we designed our compression in-house. And by the time HEVC came out in 2013, we were ready to crank it up to 8K. Of course, it took a bit of time on the market to actually be able to display that at end users' home. So we took a small detour doing things in 4K, learning all about HDR, making sure the ecosystem was ready to move on to even higher resolution. And when the TV were finally there in 2019, well, we first saw the start of the 8K association that we joined. And we did at this very show, NAB, back then, the first 8K demos with nice panels, explaining how HEVC can be leveraged to deliver 8K more efficiently and precisely at scale. We worked with Samsung, did HDR10 Plus implementation to make it really pop on HDR. And then in 2020, things got one notch higher with the advent of VVC, an even newer generation codec, more efficient, up to 50%. And we launched the first OTT channel with vExplorers with great success. The industry recognized the overall effort in terms of psychovisual parallelization, use of AI. So there was a round of Emmys being awarded. We got 3 of them, all of them basically. So we were really happy about that. And since then, AK only got more and more widespread. We made interesting implementation. We compared that to other new generation codec like AV1 or LCVC. We can discuss that later on the panel. And more recently, we deployed that in Brazil with a base layer in VVC and enhancement in LCVC. And even more recently, at Entech, a few weeks back, we did some nice demo. And I think SSI will be a good interlocutor to discuss that later on, where we realized that even film stock that are over 30 years or sometimes 40 years of age can still shine when rescanned and properly converted using IMAX technology and then encoding and displayed on end user TV. So that's not the focus of today. Today we're talking about distribution, the final encode, but it's really important to realize that 8K content, while not distributed widely today, is available. And even some 40+ year content can make a material difference to the end user when properly distributed.
So one level set here. How many of you have seen 8K before? Yeah, so quite a few. So again, we miss actually NHK here. They used to have a very beautiful, they've been pioneering this whole workflow, and we've been very inspired by NHK. But we do have a booth actually. If you have not seen what 8K looks like and things, just go check into like 8K Association. So that will explain you a lot of these things. So with that, actually, I want to move focus to main concept because of the slide here in the sequence we have. So Thomas, just tell us actually.
Yep, sure. Yeah, Thomas from Main Concept. Main Concept is leading the market since, 30 years actually. In fact, we're celebrating our 30th year now. In this broadcast market, we've been providing codec technologies for audio, video, including all the packaging in and around for these 30 years to the market. What we've started with is really, codecs from delivering, into the broadcast market, but on the production side as well. So it's everywhere within the workflow, you will find Main Concept deployed. The good thing is when, you have a codec that's once deployed, you will always have it. And that's why we see that in the market still. So we're always still deploying Entech 2 across the market. Nowadays, of course, there's new codecs. Every time there's a new codec, and the story continues with, I mean, a new evaluation. Talking about 8K, that's really where we've been starting with HEVC. I think as Thomas also said, HEVC has been kind of the first codec that was, I mean, able to do an 8K in a really good quality, but efficiently over a bandwidth that could be streamed. Traditionally also over a set-top box with a stream over the air, but nowadays it's the internet streaming. So with 8K, we've done, I mean, HEVC streaming, really nice demos as well, live events as well, and with just starting last year, DVC has come to us as a beta as well. So we've just launched that last year. Now we are bringing that to the market as a ready-to-use codec. So our technology has really been kind of integrated into the products that you see here on the NAB trade show, really. We provide the ingredients and technologies that others then bring into a final product. What we have done with BBC now, we've deployed that as an 8K kind of native codec as well. So we do also demonstrate here as an 8K kind of plus 4K plus HD resolution live encoding with 60 frames per second. So we're fully dedicated to an 8K resolution really, and think that this is something where we will have the next evaluation. It will take time, we know that. I mean, codecs in general, but also resolutions evolve. I mean, take time in the market to be adopted. There's all the kind of beginning to the end of the ecosystem that need to be deployed, but that will for sure happen. So very happy to be part of that.
Again, like 30 years of collective work, ATEM has been like put in this space. So there's a lot of collective experience and knowledge here. And again, I'm pretty sure like a tremendous amount of failures that every company has been through. So we know 1,000 ways how not to do things. So I want to like to switch gear to Simware. This is a company recently acquired by IMAX. And Ali, just tell us actually what you do in terms of like the 8K distribution content and the quality of the content.
Yeah, so thanks for the opportunity. So SimWave is basically well known for its perceptual quality metric that is not only accurate in terms of visual evaluation, but also very friendly in terms of compute. So based on that perceptual metric, we developed VOD monitor. We have a product called VOD monitor. That's basically not only defines or give you the perceptual measure across your assets, but also give you some QC tools that are widely known in the industry. Another product that we have is Live Monitor that basically gives you very, very important observability across your workflow. So in addition to that, obviously, as IMAX is basically a known brand in the theater, and it's basically a pretty much trademark for video quality, the reason IMAX acquired SimWave is basically to take that cinematic experience to the home through the streaming providers. So SimWave provides the metrics that allow you to determine what sort of quality you're really delivering to your subscribers, plus the IMAX brand with regards, for example, digital remastering and other technology. I think together we are determined to take that experience that you see in the cinematic to the home as much as possible.
So Ali mentioned like a really good point. The signal quality and the quality of that content and how that perception quality has been measured is extremely important. Because there is a less and less forgiveness when you go for like a more pixel, better pixel and faster pixel. So that require like tremendous amount of like a computing, all the even like what looks good to your human eyes as well as the technology has. So there are ways to tell why I look this content looks better, some scientific way, not just like looking at because you know our individual mileage may vary. So thanks, Ari, for bringing that perspective. So now I want to like switch gear to Spin Digital. Mauricio Mesa, CEO of Spin Digital is here. So Mauricio, just tell us like how's your journey and what are you up to here?
Thanks, Ravi, everyone. We are in Spin Digital. We're a German company. We specialize in video codecs for 8K and beyond. And one of the problems we try to solve is what you're seeing now in the slide. When we want to do live 8K encoding and streaming, we start from this very high quality 8K, 60 frames per second, HDR 10 bit, which generates a huge amount of data. It's like 48 gigabit per second, which of course we cannot transmit as it is. But on the end side, when we want to deliver over the internet, we think based on our experience that a good bit rate that is achievable now is something around 30 to 50, 60 megabit per second. And this is around 1,000 times compression. So the question is how we can do that, how we can go from 48 gigabit per second to 50 megabit per second, but still keep the so-called 8K effect, which is this thing that when you see 8K content and there is something that we don't know exactly what it is, it's a combination of HDR, resolution, field of view, and so on, that gives this super high quality. And how we can do that? Well, it's a combination of things. On the one hand, we have the codec, which the first generation of 8K was HEVC, and as my colleagues have been saying now, the next generation is coming with BBC. But this is just a starting point. The video codec gives us some basic tools, but on top of that, and also was mentioned, we need other tools like content-aware encoding, perceptual optimized encoding, advanced rate control, and putting it all together, we can really achieve this broadcast grade quality at low bit rates. And the final challenge that we have been working on is like, okay, then now by how we can do all these things, but in real-time encoding, live encoding. And that's where we are focusing now.
Thank you, Mauricio. And I believe if you can go to the demo, you can check out the demos actually BBC, so you get an idea of the compression. And just in a layman's term, like, we watch like Netflix right now in 4K, and that quality or individual bandwidth that we have home may vary. So right now here, my home, like $50 I pay, I get like a good 1 gigabit per second up and down download bandwidth. I can easily stream and watch this in live. So this is not like, what we are talking is like, something has to be done in the lab in a very specialized environment. Tokyo broadcast we did, wherever we have authorized locations, we're able to watch it. So it's not something like in a remote or like so good to be true. If you have this technology and if there's a content access, of course, content is a king. You can literally like watch it with the existing network with that given bandwidth that you have. So this is very important to know why this the group of panel talking about the compression, bringing the low light. But everyone, I think, like, just correct me if I'm wrong. All of you agree, like, by reducing the bit rate, what about the quality? You see any problem? What's kind of like in a proper threshold?
Right. So if I may start, we all agree, I think, and let you confirm that more than resolution, at some point, bitrate becomes a limiting factor. If you guys watch 8K on YouTube, at some point, some of what you will actually see is not true 8K experience that we want to push. I'm not saying it's not possible. I'm saying that on a bit-starved link, throwing more pixel at you won't actually improve your user experience. And but a good point. I mean, it's important to have that controls in place and psychovisual model that make sure to make the best use of the bits you actually have. And in some cases, that actually means reducing the resolution. But like you said as well, in many cases, you do have enough bits available. And in that case, it makes sense to crank up resolution. And if the content is there, why not deliver?
What do you want to say about this?
Yeah, I think achieving this so-called broadcast grade quality benchmark is always the objective. We don't want to do, also Thomas mentioned, 8K low quality. These two things don't combine together. So if either we keep this high quality benchmark or we switch to a different resolution. But of course, one of the difficult things is how to measure that. And that's why it's very important to have real metrics, especially when we combine encoding and perceptually optimized encoding. Most of the current other metrics are failed on that. But yeah, there is a kind of a vision where we say there is 8K broadcast grade quality, 8K effect, and we are still working on how we can preserve that.
Rizia said, it's the 8K effect, the wow effect. If that isn't there, then there's no sense in having a new codec and having a new resolution. So that's what we never should forget.
Exactly, and that's get to the point, like more pixel, better pixel, and faster pixel. What's the trade-offs? I mean, sometimes you watch 4K with high dynamic, it will be much better. But imagine that if you maintain that quality and get up the resolution and the frame rate, you just see something that is surreal that you have not experienced before. So Ali,
Yeah, see, I think when you talk about bitrate, you talk about the quality, it all depends on the complexity of the content itself, right? So I think what we're launching here, and I'll invite you to come to our IMAX booth, is basically taking that perceptual quality metric and try to use it for optimization now. So either you can derive better quality at the same bitrate, or maybe reduce your bitrate. That we think that for VOD, at least for now, could be applicable to 8K. Maybe for live, that would be the next step.
and we have two workflows we are talking. One is the file-based, which is a traditional cinema, and then this is a live, where like higher frame rates come into the picture. Because cinema side still is in 24.95 frames per second, but in live sports, you cannot use that. You don't want to find like somebody kick a football and it reaches to goalpost and there's like a lot of stutters. So I think that is a very important. So you brought very interesting point about the perceptual metrics. So I want to ask like this panel and who want to take this question. What about like perceptual quality in like an encoding? So what is that, Mauricio? Like, or anybody want to answer that?
Well, continue from what you said. I think we are trying to solve that problem from the live perspective, and this brought us to the problem that we don't have a lot of time to make decisions in the encoder. So we take the content, we have to analyze the complexity. Okay, what's going on here? Is high action sports with a lot of colors, details, and so on. Then the encoder has to decide, okay, here, to be able to keep that quality that we are talking about, I'm going to set the bit rate at this level. But in some other areas, we see no, in fact, now content is easier, not so much motion, then we can go down in bit rate. But on top of that, we can also do additional perceptual optimizations where we use models of the human visual model system, sorry, where we can say, well, look, in fact, here, we don't need all those bits because the human eye is not going to see them. And we can, in fact, grab them from there in the image and put it somewhere else where we know that this area is more, let's say, likely that we're going to have compression artifacts. And how we can do that in live encoding is a challenge, but we already have that both for HMVC and BBC. And that's a challenge, how to do it in live, but at the same time in a very effective way.
If I might add, that same logic also applies to VOD. So while in most cases not at the same high frame rate, it's still important to realize that content adaptiveness also makes sense for VOD application. And to your point, measuring this downstream after encode and making sure the user experience is optimized is important. So that's what we do at ATEM. We are very big on VOD on top of live. And we adapted our model. So without the real-time constraint, you can do a lot of things. You can go to a very high level of brute force approach. Some streaming platform have that approach. We try to be a bit smarter and reduce the time it takes to do the encode, because we still need to be efficient. But having the time to analyze the complete asset and actually define the part where the bits are most useful, like you just said, is really important. So while the ultimate goal is in many setup is this live broadcast quality, let's not forget that customers choose, like you said, and some of them want VOD, and some of them consume them over the top. And they still need to be delivered with pristine images that are true to the artist's intent.
Yeah, I can only add to that. It's we're talking about 8K. That is something that, I mean, not really is widely deployed yet. So it happens with typical like sports events or kind of events like concerts. So where people can showcase new technologies, and that's typical life. So we have really live events where the encoding has to showcase all its best, and the decisions and everything has to be done in real time. I know our codec engineers who are developing the codecs, they like typical P&R, right? I mean, when they do an improvement, I mean, one day, next day, or new sprint, they compare P&R. But every time, again, when we release a new version of the codec, we have to measure more the perception of that encoding. And it's always a fun discussion with our engineers who really think, okay, well, I can measure the difference, so it's getting better, but it's not of how our human eye works, really. So it's an interesting discussion every time. So always interesting.
Yeah, go ahead.
Yeah, I mean, to that, I just want to emphasize that basically, if you're a video provider, a service provider, and you're spending tons of money to basically get the 8K experience to the home, I think having a really observability at key point of what is really being delivered to the home is very important to us. And I think as IMAX, I think you will hear more that with 8K, we'll basically try to enhance the experience at home and make that sort of theatrical theme that IMAX is known for to the home with obviously 8K as well.
And very important point here, because cinematic world and the live broadcast, two different beast here. If you look at there's a lot of smoothness and there's a lot of focus. So there's a lot of out of focus information in the cinematic world. Live, you want to say every detail possible at the same time. One example I can give you, an HK a few years back was showing Mona Lisa painting. Actually, they shot it in an 8K, and they could really detect an underlying brush strokes of Leonardo da Vinci, which was not visible for the naked eye. So what we are talking is a really front. And even stepping aside, if you look at a medical use cases, you can literally want to see the details of the capillary when somebody takes that particular imaging. So the value of that is not just broadcast, but definitely this is leading the charge. It gives you something a surreal expression of image and art. So you appreciate a lot more what goes inside. But at the same time, on the technology side and the capture side, there's a very little forgiveness. You cannot just screw any bits and bytes. And because if you watch it, oh, I cannot see any difference. That's it. It only takes that much to make your perception, and it's very hard to change. So this company is here, collectively, including myself, we're working very hard, been through many failures, try to bring something and preserve. And it's good to see all of us, we kind of agree that quality we should not compromise at any cost. So next question right now, I want to talk about an efficiency of encoder versus the speed of encoder. Who would like to go for that?
Well, I think we touched already on that a lot, but in the end, it's also comparing, let's say, the VOD comparing with live. That's always an issue, right? Where you can have, two paths or VOD encoding. The efficiency, you can tune to a super high level. That's always kind of a beauty of the VOD encoding. When you're doing the live encoding, the efficiency, is taking every cycle of the CPU really to its power that it needs. And when we tune that, of course, there's new CPUs, you know that, Ravi. There's always new CPUs, new improvements coming. That has to be super efficient, because otherwise people wouldn't spend the hardware, cost. And that's what the other efficiency is, what we're talking about. It's of course the quality of the compression, but on the efficiency on the hardware, actually, that's another whole discussion.
So there are three approaches to an encode: scalar, vector, and matrix. What it means is the CPU, GPU, and the AI. And a lot of this is actually intertwined and combined, and individual mileage may vary. I've been just told we only have 10 minutes. Do you want me to ask more questions, or you want me to take more audience questions? We can go on and on here. So, but again, I just want to ask here, what is the forward-looking guidance here in terms of 8K? Where you think individually where it's going?
Yeah,
Not going.
I think in my opinion, I think when we went from HD to 4K, I think initially the differentiator was the resolution, right? Higher resolution. And that proved not to be the correct course. That's why we had HDR as opposed to SDR. Now for 8K, I think we need to keep in mind the immersive experience that 8K will deliver. Otherwise, from 4K. So we already have HDR. I think we're shooting for the immersive experience that 8K will deliver to the audience. And we should not, forget that.
What is your comment?
Yeah, I would say that's something very similar. Is that sometimes we are asked like, what's the single element of 8K compared to 4K or some other format? And I think in this case we say there is not a single element. There is a combination of all of them. So we have higher resolution with HDR, wide color gamut, high frame rates, and then this overall experience is what is the result of 8K. If you compromise in one of them, like, okay, or no, we cannot do 60 hertz, only 30. Oh, HDR is not good, and the 8K experience gets reduced. And just to mention on the previous point on efficiency, this is also connected to this. Like now with the new codecs like PVC, they are kind of so complex that we cannot, especially for live encoding, we cannot promise today this 50% bitrate reduction that people say always we get with a new codec. So things are starting with moderate gains, like we are already achieved something like 20-25% with moderate CPU increase. And this is the first generation, so I think this will improve over time. But yeah, we are in this first phase of the next generation codec.
Yeah, I agree. It's not a generational gap each time. It takes time for encoder to leverage all the tools and refine all the algorithm. And as the time passes, we'll improve efficiency. Get back to your initial question, I think immersivity is really the answer for the future of 8K. And by that, I mean also new form of media consumption. It's just not your plain old TV room. It could be head-mounted display. It could be new things we did not even think about yet with 5G enabling them. So in that context, the latency aspect, I would say, is an important topic. And we need to keep that in mind on top of the rest. And keep in mind that it might not just matter for traditional broadcast, but also for streaming applications.
I think I can just, Edge is actually a smart Edge sitting there. So you can download faster, there's a less buffering and you don't see, because once you're watching at that resolution, you don't want like any lapses in your frame rate or like in a quality. You want to watch it at least like a relatively constant bit rate, and quality is more important. So with that, actually, I want to like take some questions. Yeah, can you pass the mic to him? Let's share our mics.
One. So this talk is titled Next Generation Video Codecs for 8K. Everything up to this point we discussed about distribution and to the home and viewer. And as we all know, adoption for high resolution codec starts with the capturing acquisition and the content creators, and that was not really discussed here. We already, in our real world, acquiring 8K raw, or we have to make do with editing 8K with last gen DCT based codecs. So is anything that you are working on applicable to us content creators who need the iframes, who are fine with hundreds of megabits of data rate and need that higher level of different, standard of broadcast quality in the mezzanine codec phase?
I can probably take that.
Yeah, right.
Yeah, so main concept is exactly in that market. So we have, I mean, the production market, and that's where the acquisition of the content comes. It's more than just a decode. I mean, it's efficiently doing, because when you're editing, you have a timeline with a lot of content, right? You have to do, I mean, transitions. You have to add, multiple of those streams in parallel. We have the corresponding decoders to ingest 8K from real time, but also on, let's say, file-based as well. So the cameras, there are cameras that do, I mean, not only raw 8K, but also compressed 8K with an HEVC. So those are there. We work with them. We are working with the companies who provide those cameras, and we bring those, I mean, tools to ingest files and content to the market here as well. So yes, absolutely.
Any other questions? It's like you've been very knowledgeable. So I'll just give everybody a closing comment here, and then we can wrap up. I've been getting signal that our time is getting up. So, do you want to go for Thomas first? Or?
So I'll start. I want to emphasize the comment I made earlier on. There are content out there available for a while, and this content is only growing with people shooting more and more, producing more and more in 8K. So we have here a good example that the technology to distribute that content is ready. And the end users' devices are there, starting to be more and more deployed. So don't be shy, don't hesitate to contact any of us. We'll be more than happy to show you what we do. So come to our booth, check our demos, and yeah, let's get in touch.
Just want to say that, yeah, please come to our booth, especially the 8K Association. With 8K, is really seeing is believing. So you have to really have a look at the content. And it's also very important, I will say, that in the codec business or in the codec technology, when we are doing our job wrong, is when you really see it. So it's like, oh, this looks very bad. This compression artifact, blocking, banding. So if we are doing our job properly, then you don't notice things. Oh, this great, looks great. This 8K video looks fantastic. It's like being there. That means that we are doing our job properly.
Yeah, sure. Can probably just continue with inviting to our booth. Main Concept has a booth over there at the other end of this hall. Actually showing live real-time encoding 8K plus a 4K plus an HD, all in VVC live encoding. It's actually running in the cloud. It's another topic that we could talk also forever here. Comparing, let's say, a cloud to an on-prem solution. There's beauty, there's benefits of both areas, but what we're showing here is a cloud-based live encoding. So very happy to see that. Quality is impressive. Of course, because of bandwidth limitations, we can only show the HD layer here on the booth, but there's real-time encoding in 60 frames per second with 8K, 4K, and HD with VVC. So please come back.
Is there beer?
And there's beer as well now.
Oh, okay. Yeah, I invite you to come to our booth for details, but currently we have products basically for monitoring, including 8K monitoring, for perceptual quality, including also HDR. We have some metrics that you can basically monitor your Dolby Vision or HDR10 plus even. So,
We got a special permission to show some Olympic content. So thanks for 8K Association who put and brought us everyone together. And we are showing right now in our 8K Association booth. So come check out, because we're not able to go to Tokyo, and I was there, was not pretty happy time, because if you don't have audience to enjoy, so at least we brought some of the Olympic content in 8K. Just make your own mind and watch it. And 8K Association does bringing all the ecosystem partner together. And we are actually like a maintaining repository of all the greatest things happening in the 8K as a part of 8K Info Decode report. So feel free to sign up and download. And just, I want to just put one CDN thought. What data rate we are talking about here right now? 216 hours of Olympic captured at 14 gigabits per second, distributed at 80 to 100 Mbps, because that's what the cloud provider we use was capped at. More than 4.7 petabytes of data has been captured, processed, created 300 terabytes of stream that was delivered. That was only one channel, TV channel broadcasting, a feed that we are getting. So we are talking and dealing with a massive amount of data. We have not even touched base on what AI does and those things. These companies do AI using both from the quality metrics as well as from the encoding side. But this is something, as Mauricio mentioned, seeing is believing. And next time you watch anywhere 8K, just ask them, is it about more, better, faster pixel and immersive audio, all things combined? And with that, actually, I would like to thank our panelists who did a wonderful job here. And we'll next 100 years of NAB, definitely you will see things that has happened today. It's a very historic. Hopefully some of you guys will be here. And, thank you, Mike Fiddler, for doing those.